massive girl who wants to impregnate one day. I'm so sorry, did you already record?
Yeah, you just hit it. That's like the first 5 seconds of the thing.
You gotta keep it. You gotta keep it. Theory of heat. Refrigeration.
Okay.
Just keeping it real, like if they were really in class.
That's the effect I'm going for.
Yep, cool. Let's go then. Next slide, please.
So be
Section
ourselves.
1. Theory of heat, Unit 3, refrigeration and refrigerants.
Whoa, refrigeration and
My favorite.
refrigerant.
My
Wow.
favorite.
Whoa.
We're gonna do something? We're gonna learn something?
What? I've said that a few times in some of these mods when it comes to refrigerants. You better, I'm gonna fight you. Objectives. After studying this chapter, you should be able to discuss applications for high, medium, and low temperature refrigeration. Describe the term tons of refrigeration. Describe the basic refrigeration cycle. Explain the relationship between pressure and boiling points of water or other liquids. Objective continuation. Describe the function of the evaporator or cooling coil. Explain the purpose of the compressor. List the compressor's normal use in residential and light commercial buildings. Discuss the function of the condensing coil. State the purpose of the metering device. Objective continuations. List 4 characteristics to consider when choosing a refrigerant for a system. List the designated colors of refrigerant cylinders for various types of refrigerants. Describe how refrigerants can be stored or processed while refrigeration systems are being serviced.
Wow.
Next slide, please. Continuation of the objectives.
No.
Plot a refrigeration cycle of refrigerants R22, R12, R134A, and R502 on a pressure I can't say that. Wait, whoa, you skipped a, oh, I don't need to read it then? Okay. Introduction to refrigeration. Cooling preserves products and provides comfort. 1900s were the beginning of the mechanical refrigeration system. Refrigeration process temperature ranges. High temps, air conditioning, comfort. Medium temps, fresh food preservation. Low temps, frozen food preservation.
Ooh, okay, so we got 3 different types of refrigeration. These are the 3 most common, or the 3 basic.
Refrigerator? And
High, medium, and low. Huh?
Yep, low freezes my meat in my freezer.
High temperature refrigeration includes comfort, it also includes some other refrigeration too, which we'll get into. And low temperature, there's a lot of different temperatures for low temperature. So, and medium temperature is pretty much for food, fresh food, meats, milk.
Yeah, that's disgusting.
Refrigeration. Process of transferring heat from a place where it is objectionable to where it makes little or no difference. Heat naturally flows from a warmer substance to a cooler substance. Heat will flow naturally from 100-degree Fahrenheit house if the outside temperature is 80 degrees. Mechanical refrigeration is needed if the house is 80 degrees Fahrenheit and outside temperature is 100 degrees Fahrenheit. Refrigeration continue. And then there's a diagram.
Okay, so here's your first cartoon of the slide.
It's not really a cartoon, it's just a picture. Doesn't move.
As you open the box, your refrigerator at home, the warm air goes to the cold, and the cold air falls out onto the floor.
So is that why when my standing freezer went out on me, the stuff on the top started melting before the stuff on the bottom? Because it was awesome.
Could be. Yes.
Could be, that's what you just taught us. Oh, Ralph, you're 3 minutes early. Say hi to the camera. Marshall, I feel like it's your turn to read.
equipment. Some facts. It takes 144 BTU to melt 1 pound of ice at 32 degrees Fahrenheit. 2,000 pounds of ice, 1 ton, will require 288,000 BTU to melt. 144 BTU times 2,000 pounds. If the melting of 1 ton of ice takes place in 1 day, 24 hours, 12,000 BTU must be absorbed by the ice every hour. 288,000 BTU divided by 24 hours.
Okay, so that's where we get our 12,000 BTUs per ton. That's where it comes from. A ton of refrigeration is not 2,000 pounds. Okay, got that? Comment right there. 1,000 pounds, which is a ton of ice. 288,000 BTUs to melt that ice in 24 hours works out to 12,000 BTUs per hour.
Rating refrigeration equipment. 12,000 BTU per hour equals 200 BTU per minute equals 1 ton of refrigeration.
Wow. 200 a minute too.
The refrigeration process. Heat is pumped from a cool box to a warm room. Pumping of heat is similar to pumping water uphill.
The refrigeration process continued. Air conditioners pump heat from inside to the outside. Inside temperature 75 degrees Fahrenheit, outside temperature 95 degrees Fahrenheit. Cooling indoor coil temperature is 40 degrees Fahrenheit. The condenser outdoor coil temperature is 125 degrees Fahrenheit. Indoor heat travels to the indoor coil. System heat flows from the outdoor coil to the outside air.
Okay. So, we have a diagram of a air conditioning unit. Looks like this is the divider from the inside to the outside. The indoor air, this is basically about, real quick. The indoor air is absorbed into the evaporator coil. The indoor air is heat, and the heat travels through the compressor. It comes to the outdoor coil where that heat is rejected. Okay, so the heat actually gets absorbed into the refrigerant. The refrigerant moves around the system and gets to the condenser coil, and it rejects the heat from the refrigeration system. Okay? You getting that? You'll get it, don't worry about it. You'll see this enough.
Temperature and pressure relationship, some facts. Water boils at 212 degrees Fahrenheit at atmospheric pressure, 29.92 inches of mercury. Water boils at 250 degrees Fahrenheit if pressure is increased to 15 degrees or 15 psi. Water boils at 40 degrees Fahrenheit if pressure is reduced to 0.248 inches of mercury. Temperature and pressure relationship continued. Refrigerants are substances that boil at low temperatures, pressures and temperatures, and condense at high pressures and temperatures. Saturation temperature. The point at which the addition or removal of heat will result in a change of state. During a change of state, the temperature remains constant.
Okay, so we're talking about change of state, just like water changes from a liquid to a vapor. And we talked about that, right? Where it actually absorbs heat. A pound of water that absorbs, a pound of water at 212 degrees that absorbs 970 BTUs of latent heat is now steam. Okay?
refrigeration components, the evaporator absorbs heat from the area to be cooled. Compressor creates pressure difference needed to facilitate refrigerant flow through the system. Condenser rejects the system heat. Metering device regulates the refrigerant flow to the evaporator.
Okay, we're gonna go through all four components on the refrigeration system. We're not gonna spend a lot of time on them, because when you get in advanced, you will spend, there's a whole unit on each one of those components, so we will go in depth.
The evaporator, heat exchange surface uses to absorb heat, located on the low pressure side of the system between metering device and compressor. Operates at temperature lower than the medium, being cool or conditioned. Absorb heat by forming a low temperature liquid into a low temperature vapor.
Okay, so. You gonna say something?
I was just gonna continue reading, but.
No. Okay, so the evaporator. So what happens to the refrigerant in the evaporator? Somebody.
Refrigerant in the evaporator, doesn't it become a liquid? Wait, hold on, let me read this.
I don't think so, Tim.
Well, that's why I'm in this class.
It's a gas.
Are you reading along?
It was not actually
Liquid to it.
liquid.
What happens to the,
Oh, I went from vapor to liquid, didn't I? Wow.
what happens to the refrigerant in the evaporator?
It's cold.
I think it's cold.
The low pressure side, it gets cold and it drops and becomes cold.
What does the refrigerant do?
Absorbs the heat by boiling at a low temperature liquid from a low temp vapor.
Okay, so the refrigerant does what? Boils?
Yes.
Say boils?
Yes.
It boils, okay. So another term for boiling would be what?
Evaporating.
Evaporating. Evaporating. So the liquid is evaporating in the evaporator. Okay? Okay.
The evaporator continues. Refrigerant typically enters the evaporator as a liquid vapor mix, 75% liquid, 25% vapor. Superheat. The heating of a vapor above its saturation temperature ensures that no liquid refrigerant enters the compressor.
Ooh, okay. So we'll get into that too.
The evaporator continues. Superheat equals to the evaporator outlet temperature minus the evaporator saturation temperature. Design superheat is typically between 8 Fahrenheit and 12 Fahrenheit. Superheated vapor does not flow a pressure temperature relationship.
Follow. Does not follow.
Does not
Superheated
follow.
vapor does not follow this chart. Okay. There's a picture on the evaporator. Is that nice? Okay. Moving on.
The compressor pumps heat, leaven, leavening vapor from the evaporator to the condenser by increasing the refrigerant pressure. Reduces pressure on the low side of the system, increases pressure on the high side of the system.
Okay. We're talking about the compressor now. The compressor pumps. It reduces the pressure on the low side and it increases the pressure on the high side. So what is happening to the refrigerant inside the compressor?
Compressing.
Your what?
Being compressed.
Who said that?
Morris says, speak up,
Oh,
say what it says.
it compresses. It compresses, so that's why they call it the compressor,
Makes sense.
okay? I want you guys to understand and get this, because I don't want to see you guys over there in advanced lab saying, which one's the evaporator and which one's the condenser?
Steve never taught us. Common compressors types include the scroll, reciprocating, and the rotary. Positive displacement compressors require that the compressed gas be moved to the condenser.
Okay, they all do that, they all move the gas to the condenser, okay? So, here we have those three types of compressors. So as you can see.
That's a cartoon right there.
It's a movie,
Yes.
it's a GIF.
Okay.
Okay, so the rotary, and you can see how it's
Rotates.
elongated. The gas comes in here, and it rolls around and compresses and pushes it out. Isn't that kind of just simple, right?
Looks like an engine.
Yeah, it's like a little rotary engine, right? Now, the scroll down here uses two plates. One is stationary, the other one oscillates. It doesn't spin, it oscillates. It just runs in a little oscillating fashion. As it does that, it moves the refrigerant around those little gaps and it pushes it out the center. Isn't that exciting? Okay, I have some here. You guys want to, you guys want some hands-on?
Yep.
Okay, here you go. Hands-on, who wants it first? Oh, you want.
You made it look a lot lighter.
Oh, that's
Okay. So the reciprocating compressor, it goes up and down. That's why they call it reciprocating, okay? The main difference between these two and this one, as you can see, when that piston hits top, when it's at top dead center, there's a space in between the head and the piston, right? Because otherwise the valve would hit the top of the compressor. So that space in between there is called clearance volume. And that's the only compressor that'll have clearance volume. That makes it not as efficient as these. Because as you can see, these don't have any clearance volume. See that? We good with that so far? Oh boy.
The condenser rejects sensible and length heat from the system that was absorbed by compressor and evaporator. Locate on the high pressure side of the system. The refrigerant condensed from a high temperature vapor to a high temperature liquid.
Okay, so what do we got here? Yeah, go ahead, smile when you say that.
The condenser. Condensing temperature is determined by the high side pressure in the system. Refrigerant is subcooled at the outlet of the condenser. Subcooling. The cooling of liquid refrigerant below its saturated temperature. The condenser continues. Subcooling. Standard air-cooled systems are designed to operate with a minimum of 10 Fahrenheit of subcooling. High efficiency condenser operates with more subcooling than a standard efficiency system. determined by subtracting the condenser saturation temperature from the condenser outlet temperature.
Okay, so, we'll go back here to the condenser. Okay. So what happens to the refrigerant in the condenser?
Condenses.
What?
Condenses.
Yeah, it says right there. So it turns from a vapor into a liquid, and they call that condensing. That's why they call it a condenser. Okay? So that's why the liquid gets condensed.
To a vapor?
No, vapor to liquid.
Condensed.
Vapor to liquid.
It is right there, high temperature. Refrigerant condenses from high temperature vapor to a high temperature liquid. Okay.
Got
Are you reading along?
Yes.
I hope so, he's the one reading.
Okay, so here's a cartoon of the condenser. Comes out of the compressor at roughly 200 degrees Fahrenheit. The pressure on that side of the system is 278 PSI G. Okay, as it travels through the condenser, it drops down in temperature to the condensing point, which is 125. So it's gonna maintain 125 degrees all throughout that condenser until it reaches about there. Then it drops even below, it drops further. So at this point right here, there's 5 degrees subcooling. So it's cooled, it's 100% liquid. It exits the condenser as a liquid, and as you can see here, it's 110 degrees. So that is 15 degrees subcooling at this point. So all during this process, the pressure stays the same. It doesn't matter where you're checking the pressure, it's always gonna be 278 in this cartoon here. Okay? You seeing that? Seeing that? And while that's happening, outdoor ambient air is blowing across the condenser coil, keeping it cold, or keeping it cooler, and it's pushing the heat out to the outside air. Okay. Got it? Yeah. Getting an idea? Okay. This would be a good time for a test, huh?
No, don't.
Dude.
Refrigerant metering device controls the flow of subcooled liquid from the condenser to the evaporator. Creates a pressure drop between the high and low pressure sides of the system. About 25% of the liquid leaving the metering device immediately vaporizes, which is called flash gas. 3 commonly used metering devices are the capillary tube, the automatic expansion valve, and the thermostatic expansion valve.
Okay, so as refrigerant flows through the metering device, this creates the pressure drop from the high side to the low side. Okay? So what's happening to the refrigerant in the metering device?
Turning from liquid to gas,
Not completely.
25%.
Okay. What's another word that's gonna be used for what the refrigerant is being, for what the metering device is doing to the refrigerant?
Vaporizing.
No, that's not the word I'm looking for.
Flash gas.
No, that's not the- that happens in the evaporator, evaporating.
Boil.
Makes it
No.
cold.
Expanding.
Huh?
Expanding.
cause it to expand, what else?
Changes the pressure.
Yeah,
Makes it cold snap.
okay. Okay, so what happens to the refrigerant inside the metering device? It meters it. Thus, that's why they call it a metering device, okay? This is a metering device. This is a capillary tube. It's a very small tube, and those tubes are measured to a certain length for a certain tonnage. Okay? Yeah, I don't have a picture of the other one, so that's okay. So, we'll come back to the refrigeration system again. Outside air is 95 degrees, the condenser is 125 degrees. So 95 and 125 is the delta T, right? Remember delta T?
Yep.
Okay, so we have a 30 degree delta T. Okay, so that allows the heat to transfer. So which direction does the heat go?
Down. Wait. Heat up.
Hot to cold.
Oh, yeah.
We need to watch that video again. So it's going from hot to not so hot, okay? So the heat's gonna travel naturally, it's gonna travel from the 125 degree coil to the outdoor ambient temperature. The same way, it's gonna absorb heat from the inside because you have an inside temperature of, where is it? I don't see it.
You have it, you had your ruler on it. 75.
Right here, room air temperature 75. So you got 75 degree air blowing over this coil, which is, what temperature is that coil?
40.
40 degrees, right? So you have a delta T of 35, right? Yeah?
Yeah.
Okay, so the higher the delta T, the faster the heat transfer. So as that air from the room, we'll bring it over here, as the air from the room blows over that evaporator coil, that 40 degree evaporator coil, it absorbs heat in the room, thus blowing out the air at approximately 55 degrees. Okay? Getting that so far? That is the cooling effect of the evaporator coil. As the refrigerant evaporates or the refrigerant boils, it boils at 40 degrees, or it's changing state. Same thing that's happening is it's changing state, it's boiling, or it's saturating. Same thing. Okay. Notice that the pressures on this system, we got a pressure right here of 278 psig, pressure over here of 278 psig, a pressure down here of 278 psig. All through the high side of the system, it's a constant pressure. Then the same way with the low side of the system, it's a constant pressure of 69 psig all throughout the entire low side of the system until it reaches the compressor. Is that grasping that? Yeah. Okay. Yeah.
Refrigerants include R12, primarily for high/medium temperature refrigeration applications, which was banned in 1996. R22 primarily air conditioning applications, slated for the total phase out in 2020. R500 and R502 banned in 1996. R134A replacement for R12 with retrofit. Replacements for R22 include R410A and R407C.
Okay, so here's our refrigerants that have been banned. 500, 502.
Why did R500 get banned if it has like a 500 R value? Isn't that good?
What?
Isn't the higher the R value, the
No,
more? No?
no, that number just indicates the blend, the type of blend. Like the 400 series
Mm-hmm.
is it's a certain blend with a certain amount of refrigerants in there that make it that. The R22, the 12 are not blends. They're single components.
So what, the 500 was banned just because there's something in there that's not safe?
Yes. Yeah, whether it's 502, 500, there was, 134 is slated for phase out too. So they're gonna get rid of 134. A lot of the replacements that they've got on the market for R22 are already, banned because they had, little amounts of R22 in there. So you can change the proportion of a blend and say you got 5% R22 in that blend. Okay, now it's classified as a new refrigerant. Okay, so once before 22 got banned, they would stop making that and they would make a new refrigerant that had maybe 10% R22 in it, and that would be classified as another refrigerant. So they would keep putting this stuff on the market and classifying as new refrigerants or new blends, and that would keep them from being phased out. So the R22 include 407C was the first replacement for R22. It's not a very good replacement. Now they have even better replacements. Okay, so some of the replacements are 458A, 438A, 427, 422, B, and C. So there's a lot of refrigerant replacements for R22 that are on the market right now, because a lot of systems, you go on a system that's R22, for a 30-pound jug, or R22 is about $1,000. 30-pound jug of R407 is about $150. So the replacements are a lot cheaper than the original R22. If you can find R22, they're not allowed to manufacture it anymore. So there's still some out there.
So we find it, just snatch it up.
Yeah, it's a good price. But it's gone to the point, see, I was around when R22 went away. And I know what happened to the industry when that dropped off and they quit manufacturing it.
The R12 or the R22?
R12. So really what happened was they had all of these replacements go on the market for R12, and everybody got to use all these different types of blended refrigerants and stuff, and it finally worked out to whatever the industry wanted to use. So by way of technicians and stuff like that, they finally, and they know by sales, the most popular. So they finally settled down with a refrigerant that they called Hot Shot.
Called what?
Hot Shot. hot shock, which is a R416, I believe. But that, that refrigerant,
Can you get one, please? He's got COVID.
everybody put your mask on.
I got mine on.
Okay. So the industry is gonna settle down to one, maybe two replacements for R22 that's the most popular. So you're gonna be experimenting, when you get out in the field, you're gonna be experimenting a lot with different types of blends and different types of refrigerants for the replacement for R22. Some are gonna be obviously better than others. And you're just gonna pick the ones you like.
Steve, so once the system has R22, you can't put, so you could put R410,
Nothing.
no? So you have to take all out
Yes.
and then put,
That's why I actually disagree with this, because it's not a replacement. Our 410 system has to be built for 410. So 410 is not replaceable with anything, and it does not replace anything. 410 is a special refrigerant, created by Carrier. And, they built their systems to handle the pressure. This is a higher pressure refrigerant, what they call high pressure. So we're gonna have higher pressures on that. So you can't just put a high pressure refrigerant in a medium pressure system like R22. It'll blow it up. Okay? But 407 is a medium pressure. 422, 438 are all medium pressures. Okay? Got that? Got that? Understand that a little bit? So it's eventually the industry is gonna settle down to one or two good replacements. So in order for this to be replaced, if you're gonna put our 407C in a system that has R22 in it, one of the things you have to do is you have to dump that oil out of the compressor and change the oil.
Is that a pain in the ass or is it kind of?
Yep. Especially if there are other refrigerants out there that do not require the oil change. It's a whole lot faster, it's a whole lot cheaper for the customer to just take the refrigerant out and put new refrigerant in, rather than replacing the oil. Because the R22.
How long is the process of dumping the oil out? Is it like an hour, half
You gotta
hour?
pull that, you gotta unsolder it and unbolt it. Pull it out, turn it upside down, dump all the oil out, measure it, and then you measure whatever you took out and you put back in.
Okay.
You physically have to drain it.
Huh? What?
You have to like physically take it out.
Yes, physically take it out.
So pretty much the pain in the ass part is unbolting it, unsoldering it, resoldering it, and rebolting it. So,
Yeah.
sounds fun, but that would be a pain in the
It
ass.
takes a lot of time.
Think about what? Yeah. Sounds like.
So if you can eliminate that part of the process, you've saved some time. So, a customer has an R22 system with a leak on it, and it's a couple pounds low, a few pounds low. The option is to top it off with R22 if you have it for $200 a pound, or take the refrigerant out, 5 pounds or so, take it out, and then replace it with a less expensive refrigerant, like 428 or 427.
But then we don't have to dump the oil on that then, right? 'Cause we're-
No, not on 427 or 428 or 438 or 450. Yes, the 407C requires alkylbenzene oil. And what's in the R22 systems, the older R22, 12, 50, 100, 502 are all mineral oil. So the refrigerants aren't really compatible with that type of oil, so. You want one that's gonna be compatible. That's so far.
Refrigerants must be safe. Designed to protect people from sickness, injury, and death. Proper ventilation is required. Refrigerants can displace oxygen if permitted to accumulate. Modern refrigerants are non-toxic. When burned, toxic corrosive gases are created. Did I say that right?
Yeah. Okay, so what they're saying is, these refrigerants are designed to be safe. The only problem we have with them is the refrigerants can displace oxygen. You know what displace means? Means
Take away.
moves the oxygen out. It doesn't mix. It doesn't mix with refrigerant. Okay, that could be a problem, right? So if you're breathing refrigerant, you're not getting any oxygen. Okay, so there used to be a refrigerant called R123, which is a low pressure refrigerant used in chillers. That was pretty toxic. But that's been off the market for some time now. And there's also ammonia, which is highly toxic. So they're not, that's a refrigerant, and also the other refrigerants that are out there that they seem to be using now is R600 and R290, which is butane and propane. So you can see the issue with those.
Yeah.
Das ist Feuerspulen.
Sounds about right.
Okay, so the refrigerants nowadays, for the most part, are gonna be safe except if you burn the refrigerant. So if you're burning refrigerant, I don't know why you would be burning refrigerant.
Ordinance.
If you're unsweating a compressor or something like that, and there's residual refrigerant in there, you could be burning some refrigerant as it starts to come out. So the toxic corrosive gases that are created is phosgene gas. You ever heard of phosgene? Phosgene gas. Phosgene gas was a chemical weapon used in World War I. It was the chemical weapon that killed most of our
Jews.
servicemen. Yeah, of all the different chemicals, weapons that the Germans used, that was the one that killed. So phosgene, it creates phosgene gas by burning. Okay? So don't sniff it. If you burn it, don't sniff it.
To snort it.
No, don't snort it.
You wanna die,
Yeah.
I just wanna party this weekend. It's getting off work.
So you guys getting scared yet? You getting scared yet?
Nope, I'm up for the challenge. I live dangerously.
Well, it's funny because I knew about this, and about, 5 years into the trade, I'm thinking, gee, I wonder if I've been breathing this phosgene gas all along and
Probably.
I'm dead or I'm gonna die, Then a few weeks after that, I got a whiff of it, and I went, oh, that's what it is.
Did you pass out, or you just like,
Yeah.
It's like the worst smell, it burns your throat, it sucks. It's like the worst suck imaginable.
You ever smoke ammonia?
yes?
No? Every time I do this mod, I forget, I need to buy a bottle of ammonia.
Just,
And then
isn't that what the medical people snap?
And then just pass it around and have everybody sniff it.
Sounds like
And that
fun.
gives you an idea of phosgene gas.
Isn't that what, when you pass out, they have those little snappy things?
Smelling salts.
I'm sure you know. That stuff's awful.
So, if you wanna know what it smells like, don't worry about it. You'll know. If you get a whiff of it, you'll know. I won't have to explain it for you.
Well, then you're just doing your job, and then, poison happens.
Refrigerants must be detectable. Methods used for detecting refrigerant leaks. Soap bubble solution, pinpoints leaks. Halide leak detector uses an open flame. Electronic leak detector, general area leaks. Ultraviolet leak detector, pinpoints leaks. Ultrasonic leak detector uses sound waves.
Oh, so we got different types of leak detectors that we can use to detect refrigerant. One of the things that we found out that some of the older leak detectors, especially the older electric leak detectors, were only designed for those three refrigerants that we normally use, which was R12, R22, and R502. They detect the halogen in the refrigerant. Okay, nowadays, there's no halogen in the refrigerant, no fluorine or chlorine. The new detectors have gotta be able to detect all of the flames and all of the refrigerants out there, okay?
That makes sense, cause like sitting there having to do the soap bubble solution just seems like a very long process.
Well, I use a couple of different methods.
Isn't that where you just spray it onto it?
Yeah, you're gonna find the leak first, you're gonna say it's over here, it's right there, so you're gonna use soap bubbles to find out exactly where it is. So you don't have to.
So what
guess.
happens when we do the halide one and using open flames? What does it do? Just,
Okay, if you got a leak, it burns the refrigerant.
okay.
That would be a good way to test your nose. I don't know if they still use those anymore, but
Does the flame get bigger?
no. The copper disc on the head of the, it's just a little head, a propane torch, and the flame heats up a copper disc, red,
Okay.
and when the refrigerant goes over it, it turns green.
Okay.
It changes color.
Thanks.
But it's a very inexpensive leak detector. So,
Much cheaper than.
if your boss says you need to go get a leak detector, you can probably buy one for about $30. And you say, yeah, I got one. I got a leak detector. That's what
I can just get off of Amazon. Can you?
Huh?
Can you get that off of Amazon?
It's my guess.
I just didn't know, like, you know, look it up right now. Amazon right now. Someone read, Marshall. Rob. Kevin.
General refrigerant notes include, should boil at low temperatures at atmospheric pressure. It is illegal to intentionally vent refrigerant into the atmosphere. Stiff fines or violations. Mandatory certification for technicians. Refrigerant phase-out schedule set by the EPA. Refrigerant cylinders, drums, color-coded. Recovery, recycling, and cleaning of refrigerants. Refrigerant recovery is mandatory during service and installation operations. Intended to reduce the emissions of CFC, HCFC, and HFC refrigerants. Recovery equipment must be used according to manufacturer instructions.
Well, duh. Okay. Let's see. Yeah. I'll go to the summary, you wanna take?
Yeah, let's just go through the summary real quick.
Okay.
Summary, common refrigeration temperature ranges are high, medium, and low. High temperature refrigeration is also referred to as air conditioning or comfort cooling. Refrigeration process of transferring heat from where it is ejectable to where it makes little or no difference. The continuation of summary. Heat flows naturally from warm to cold substances. Saturated refrigerants follow a P/T relationship. 1 ton of refrigerant is equal to 1200 BTU/hour.
12,000.
Oh, 12,000, what did I say?
1,200.
Oh, my bad. The evaporator is the component that absorbs heat. Continuation. The condenser is the component that rejects heat. The metering device is the component that regulates refrigerant flows to the evaporator. The compressor creates the pressure difference in the system that allows the refrigerant to flow. Continuation. Superheat is equal to evaporator outlet temperature minus evaporated saturation temperature. Subcooling is equal to the condenser saturation temperature minus the condenser outlet temperature. Superheat and subcooled refrigerants do not follow a pressure-temperature relationship. Continuation. Modern refrigerants must be safe and detectable. The pressure, thank you. Yes, chart provides a graphical representation, thank you, of a refrigerant system.
Good one.
Refrigeration system, son of a gun.
Let's continue.